Welcome to the NLP MD podcast. It's a podcast where we explore the intersection of healthcare and modern AI. I'm your host, Dr. Justin Schrager, practicing board-certified emergency physician with over a decade of clinical experience. I'm also the co-founder and chief medical officer of Vital Software. Today, we're going to take a deep dive into the world of artificial intelligence in healthcare, specifically addressing the concerns and opportunities, I think, around language models like GPT. While many worry about AI hallucinations, poor quality, bizarre interpretations, and of course inaccuracies, we'll explore how these challenges may be more manageable than they were just a year ago, even 6 months ago, thanks to emerging solutions and safeguards. Joining me today are two exceptional guests who are at the forefront of implementing AI in the healthcare setting. I have Dr. Nick Sterling, who's an emergency physician in Greenville, South Carolina, and he's also the Director of Clinical Innovation and Research at Vital. He has an MD and a PhD. Nick brings a very unique perspective, and I think he bridges the clinical and technological worlds very nicely, and you'll hear from him in a minute. We also have Mac Delaney, who's the Director of Machine Learning at Vital. He also brings a decade of experience in software and machine learning, and he has expertise in implementing AI solutions in healthcare. And he's the perfect person to help us understand the technical aspects of making AI safer and what you can do as an engineer or as a doctor working with product and engineering teams to implement these types of techniques. We're going to explore how recent advances in AI are making it possible to deliver more accurate, safer, more trustworthy healthcare information, which can be accessed directly by patients. I think we have a tremendous opportunity here to give Dr. Google a big glow up. So let's talk about it with equanimity. Whether you're a healthcare professional who's curious about implementing AI in your practice, or simply interested in understanding how these technologies are being made safer for medical use, this conversation will give you valuable insights into where we are and where we're headed and where we've been over this last crazy year and a half. So without further ado, let's begin. All right, here we go. Justin Schrager here. I'm here with Nick Sterling, Mac Delaney. We're going to do a quick podcast, and today's topic is going to be a very casual discussion of extremely complicated AI technology that I think actually is probably relevant to physicians, people who work in the hospital, and that I think, and my hunch, is that what we know so far about AI models, hallucinations, how to prevent hallucinations, quality reviews, all of the boogeymen that we're hearing about day in and day out is probably something that was more of a problem a year ago when we started working with this stuff than it is now. And there are new advanced solutions that I wanted to bring this crew together for. Just to give, I guess, time for a Luddite like me to ask questions and for Mac and Nick to flex a little bit on kind of what the new cutting edge is outside the ivory tower, outside the hand-wringing of LinkedIn and other sort of like social media sources with regard to where LLMs are, specifically AI, and how we might be able to use them in the healthcare setting. So I'm going to kick it over really quick to Nick and Mac. Maybe you could introduce yourselves, Nick, first, if you don't mind.
Sure. Thanks, Justin. I'm Nick Sterling. I'm an ER doc. I practice in Greenville, South Carolina. I'm Director of Clinical Innovation and Research at Vital Software.
Nice. And I'm Mac. I'm Director of Machine Learning at Vital. So background of 10 years in software and machine learning.
Great. Both of these guys work with me at Vital. It should be no surprise how I twisted their arm into joining me today, but that's not why we're here. We're not here to talk about the software. We're here to talk about the technology, and specifically the way that we are, let's say we, as in people building modern consumer software that uses LLMs as a tool or a tool in our toolkit, are making sure that it is safe, I guess, or valid or precise. So maybe Mac, you could, if you don't mind, giving a natural history of the last year and a half. I can't believe, like, we started using GPT in the early access, right? We were like we were OGs with GPT, right? And that seems like a it seems like a million years ago. So maybe you could talk to me a little bit about your journey over the last 2 years and just sort of like what you've seen and how things have changed and improved.
Yeah, it's certainly been frantic. So before GPT and language models, would have pretty classical machine learning use cases. So how long is the patient going to wait? Is the patient going to be septic or not septic? And there are decades worth of kind of frameworks to evaluate these. So, if someone's septic or not, it's a binary classifier. Are they true positive, false positive? And you can optimize your model to minimize the bad number and optimize the good number. Similarly, with the wait time, you can get a pretty easy error, like is it 10 minutes off, is it an hour off, and optimize against that. GPT and other language models came out, and suddenly so much more intelligence or application was possible, and we all kind of frantically rushed to implement and test things. And most of that testing initially was kind of anecdotal. Check 10 to 20 kind of examples. Definitely more if it's like medically scary. Often less if it's just, doing something a little bit less scary. And then roll it out into production and see how it goes. And I think recently, particularly at Vital, we've really cracked the nut on how to be a lot more rigid in how we examine what things are doing, particularly as like the use cases get a bit crazier. So one example is at Vital, where we recommend after a patient's visit, some follow-up specialists that they should see, if they should see one, based on, does the insurance match? Does the person specialize at, in wrist surgeries and the person has a broken wrist? And these are things that you don't want to get wrong, and there's lots of different edge cases. The aperture of what's possible with LLMs is widened, the aperture of what can go wrong has widened as well. So we're now using what we call kind of judge in the loop. So we'll have an LLM evaluate itself, or a smarter LLM evaluate another LLM. And so you can get big sample here. Is the main thing. So you can have it review thousands of samples, which a human couldn't do efficiently. And you can also get metrics. So you can have the LLM output as a safe 1 to 5, is this of high quality. You can, cut that by different kind of use case types. How good are we, like recommended orthopedic surgeons versus neurologists, things like that.
You said something really interesting there, and this is something that I've lived through, Nick and I, which is basically having a human evaluate the output of the models. And so I think I don't want to put the words in the mouths of my colleagues, especially medical colleagues and researchers that are doing work in this area, but there's generally two schools of thought. There's the people that want LLMs to be used as a drug device, meaning you have to go through FDA clearance. They're monolithic. You cannot update the model methodology without going back through the methodology of the FDA. To publish all the input, output, it has to be explainable. The whole thing, right? It's like getting which is fine. It's the safest way to do things. Or you put a human in the loop, right? So the model runs itself. Instead of sharing the output of the model with, the patient in your example, it would go to a doctor, a nurse first to review it, right? And so there's two ways to do it. One is to pass the buck onto a human being who's reading it, or to make it so extraordinarily safe that it is akin to a drug or a medical device. There aren't really any LLMs old enough for any of them to have gone through the FDA process yet. Not really, right? And if they did, by this point, it would be like GPT-3, right? Just because of how quickly things go through that process. Things are changing so dramatically that, maybe Nick, you can speak to this, but like the evolution of the LLMs over the last 2 years, is pretty wild. There's no way for academics to keep up with it. No way for the FDA to keep up with it. No way for a lay person definitely to keep up with sort of the quality and precision of these models. So maybe you could talk a little bit about that, Nick, just sort of like your own experience coming from, you're an ER doctor and you have a PhD and you've been doing machine learning or sort of ML and AI research with me for a decade. We've been working on stuff together for a decade. So what's the last couple of years been like for you?
Yeah, I also came out of academia where science progresses really slowly and iteratively. You study a particular hypothesis and you test it, and then you do peer review on it, and it takes 6 months to get published. You get grant funding, and then it's an extremely slow iterative process. And during that time, some basic methodologies were gaining popularity, like support vector machines, neural nets, that kind of thing. And then all of a sudden, paragraph vectors, word vectors, and paragraph vectors pop onto the scene. And you and I did a study using those, and it was amazing. That technology at that time,
Yeah.
GPT 3.5, a couple of years ago, I mean, it makes your head spin. So to give context, I guess, rewinding a year and a half ago or so, we did a study using GPT 3.5 to validate whether we could accurately translate radiology reports for patients in a very safe way, capture every ounce of relevant information, not leave anything out. And importantly, the concern at the time was don't hallucinate. That was like rule number one. And it still is.
You were taking an LLM, putting a radiology note, a radiology report into it, and saying, rewrite this for a normal person to read.
Exactly. Yep. Comprehensible to an audience without medical training, using plain English. And it did an amazing job. It was 99.2% safety across like 2,000 radiology studies. Now, I was using ChatGPT 3.5. Since then, these later machine learning models have blown everything since then out of the water. And it's really, when I reflect on it, I think we're converging on a time where we're going to have to ask the question, there's risk in everything, right? Like you can deploy a language model to answer patient questions, and there's some inherent risk in doing that. But when they're getting so good, there's also a risk of withholding information from patients and not allowing them to use really good tools to understand their healthcare and understand their health conditions. And I think that we're kind of converging on that time at this moment where I think we really need to reevaluate the benefit and risk equation. One of the ways that we're doing that, as Mac alluded to, is in addition to medical review of all these products, is using AI judges. And so you're basically setting up one AI to monitor the output of other AIs to make sure it's safe, make sure it's high quality. Judges are not perfect. I'd say they catch about 75% of misses. So let's say, for example, let's use our prior example of radiology reports where you're 99.2% safe across 2,000 studies using an inferior language model. You get rid of 75% of those unsafe, so the 0.8, and you bring it down to essentially negligible. This is one technique. I don't know if we're going to need it in the future, probably for the next couple of years, but it's rapidly evolving.
Yeah, that's an interesting point. So, maybe to go back a little bit to something Max said and to ask you another question, basically, when you said that, human reviewers were having to read these things, this is what we did in that study, right? We had humans compare the output of the LLM, translating a doctor's note into plain English, compared to essentially what they would deem to be safe or good, right? Like if a doctor had 10 minutes to sit down with you at the bedside in the hospital and read through your CAT scan and be like, here's what this means, here's what this means, here's what this means in plain English. Like that would be an ideal circumstance, not what happens in the real world, right? But what I noticed in there is that when the LLM hallucinated specifically, it was kind of hard to catch. And my theory, and I don't know this for sure, my theory is that because the models are trained on, a reinforcement methodology, and I think that reinforcement is sort of a positive methodology, if that makes sense. Like, this is like in my stupid brain, but like I'm imagining in the early days of GPT, they were going, write a Shakespearean sonnet about a calico cat. And then they took the output of that and they showed it to a bunch of English speakers and they were like, is this a good sonnet about a calico cat? And the people reading it were like, yeah, that's good. Or they were, no, that's bad. Why was it bad? Was it bad because they hallucinated that the sonnet was about a dog, or was it that it was good because it really was a good sonnet, or it was good because, or it was bad because it was just like poorly written, but it did qualify as an appropriate sonnet about a calico cat? I don't know, but in my mind, the models they err towards optimism. Like, that's always been that's a known problem we have to fight against, right? We're trying to get them to be euthymic, but I'm just kind of wondering, in the circumstance where you're relying on a human in the loop, which happens a lot in medicine, right? Like, there are all these systems that'll transcribe a doctor and patient's conversation and write a medical note for you. Then you as a doctor need to read that note and edit it and finalize it, right? Honestly, sometimes it's hard to catch those little things that are in there. Like little things like it made up a date, or it made up a color, or it made up like one line of text and you're reading through thousand lines per patient trying to go quickly. I'm wondering if you see the judges as a potential solution even for that. Because Nick talked about the scalability of the judges, but if you're going in mass and you're not reviewing everything individually.
100%. I think it's huge. So like, as Nick said, like if you've got a 99.2% safety rate, you might have to review the human 1,000 samples to get 8 examples of a bad thing. So
yeah,
and those unsafe things can just be, a 5 or 6 word hallucination, which is easy to miss. So if you can have a judge in the loop that, as Nick said, might catch 3/4, it takes you, an hour to push through 10,000 examples. It should be 800, judging by our safety rate. We get to 600 caught by the judge, and you can quickly see, those hallucinations. The great thing about the judge is it can speak like a human and tell you why it found something unsafe or where the hallucination was. It can point you straight at it. If it's wrong, you can update the prompt and iterate over time. And often, as well, just to like give another credence to why that sampling's really good, is often there's hallucinations that be patterns. So 20% of them because of reason X. If you're reviewing 1,000 as a sample to get 8, you won't see that pattern. If you're reviewing 10 to 20,000 to get 6 to 800, or 6 to 1,200 for the judge, you will see that pattern, and you can quickly accommodate that. So.
Right. So do you see this as a solution that's like future proofing? Nick was saying the LLMs are getting so good that hallucinations will be fewer, harder to catch. There's going to be, if you are a human reviewer, the false negative rate is going to be quite high. I would say not high. The false negative rate is going to be potentially infinite if it's hiding rare hallucinations and hiding them well. So do you see this as something that like should be bog standard for people using LLMs in production like this?
I think so, certainly. Like, as you say, we're kind of riding that asymptote down, right, where all the obvious hallucinations have kind of, they pushed out of the model through all these rounds of reinforcement learning. There was a big kind of feedback thing early.
So who's the boogeyman in the future then, Nick? Who's gonna?
It's a good question.
So what you're saying is, if I'm worried about hallucinations, I should be less worried about it now because there are new tools to deal with them, and the models are not hallucinating as much. What's the boogeyman? Who's the boogeyman?
Well, I would say 2 things. One is that the reason I say we may only need judges for a couple of years is because I think that, number one, the models are getting really good, but also they're incorporating more advanced reasoning, and I think that they will kind of judge themselves. But I think we actually, in one of our experiments that we ran recently, we uncovered a classical problem in computing, which is garbage in, garbage out. And I actually think that that's probably going to be the boogeyman for companies that aren't prepared for it. So let's say, for example, you're an AI company and you have some kind of, maybe you're a medical AI company, and you just want to chuck all patient data at this language model, but you're not really checking it. You're not really checking it for quality, standardization. You're going to end up with a lot of junk going into the model. Or even worse, for hallucinations, let's say on an individual patient level, like let's say that there are no physician notes. That's a way to make a model hallucinate. And so it's really important to have safeguards around those types of things. Like if if you're accidentally feeding in like a short triage note, for example, or like maybe even like just like a 1 sentence update progress note into a language model, that's a pretty surefire way. That's your highest chance of hallucinating right there. So I think garbage in, garbage out is just going to be probably the thing that companies deal with as there's more data.
So the same thing that we've been dealing with in statistics forever. It's field services research forever. Is that
dealing with for 4 decades.
It's no different. All right.
Yeah.
I like it though. Mac, how expensive is it to run a internal affairs on your own model? And what types of model characteristics are you looking for in this sort of like I don't know what you want. What do you call this thing? It's like a chaperone for the dance or something.
Yeah, AI judge in the loop, Nick.
AI
LLM judge in the loop.
Yeah,
something like
I like
that.
it. I think we should coin it.
The hallucination
it.
police. It
I
sounds
like
like Minority Report.
It's Max judge in the loop.
I like Minority Report.
I do too. I'm a bit of a sci-fi butt, but I think that one works well. It's sort of like we're going to prevent something from happening in the future that didn't happen. Yes.
Totally. Yes. Yeah.
That's so good.
All right, cool. That's what we're going to call it. All right. So if you want to run your own Minority Report, what is it going to cost you? And
it's extremely cheap. So, cost per token is approaching the just cost of inference, which is very low. And if you've got a high quantity of or high volume of calls per day anyway for your feature, whatever it is, so we ingest 40,000 clinical notes a day. It kind of taxonomizes them and then into our domain. So you can have, what's that? 1% of that is 400. So we can have 400 judge calls pretty easily, right? Increasing cost by 1%. That's not much.
Okay, so it's definitely worth doing. Was it hard to implement?
I don't think so. What would you say, Nick? Well, I was actually just going to touch on that for a second. About a year ago, maybe it was a little more, because about a year ago, we were starting to experiment with judges, and that was with, I think, ChatGPT 4 at that time, if I recall. The thing that we ran into was context window. So just token limitations. So we would pass in the original note, and we would pass in the LLMs, LLM number one's output, and then we would ask the judge, are there any contradictions between the clinical data and the AI data? And often, probably 20% of the time, we would just cap out the tokens, and that's no longer an issue for most cases this time. So I think implementation-wise, it's getting easier too.
Yeah, I think it's certainly been in the last 3 to 6 months. There's per token prices, the quality of the model have meant that we've gotten to this place where you can kind of all you can eat on the judge sampling size to get yourself up to that daily number where you've got the statistical power you need to.
So I just want to talk about that. That's crazy that we were going from a time when we were pinching pennies, cutting down prompt length, all kinds of things like that. Now we're just kind of free to do this sort of thing. It's not that we didn't. Well, I don't know. Maybe did you know about this when we were working on this back in the day? Was this like a known idea, or is this a relatively new sort of strategy for doing this work?
We've done it in research, certainly. We actually had we had a minor incident at work because we were running this on a research task, and AWS turned our AWS sub account off because they thought it was, illicit activity or something. We've certainly done it for research and evaluation, but only just recently has it been kind of this point where you can just always on and not really think about it. And to Nick's point, some of our input prompts are over 100K tokens regularly, and the model will still handle that in context and give a good response.
Max, something I really love that you've done recently that I feel like it's kind of like a key, like an unlock, is mass judging, I guess you might say. So in other words, like it's one thing to say, okay, a single patient has a radiology report, we're going to translate it, pass it through a judge, see if it's safe or not, and block it if it's not. But it's another to run 10,000 of these through and then get quantitative metrics, which you've outlined on a dashboard. You have all the stats, rate versus not as good, whatever. And because what that means is the way, and it's still partly this way, but when we used to change a prompt to make output better, the medical team would have to go through and review 1,000 studies with that one small prompt change. And now we can at least have some relative sense of is this heading in the right direction? If we make this small prompt change here, let's say we add this one additional thing, maybe it's identifying a sensitive topic or something like that. We can get a sense of all right, is this likely to be the wrong direction or likely to be the right direction? And then medical can review what is more likely to be the positive outcome. But it really gives you a sense of how to tweak these prompts for the best performance.
That's so interesting. You said that. I mean, when we were working on, our classic AI modeling projects back in the day, we would tweak everything to get to the most optimum, C statistic or whatever we were looking for, right? And that was what we published. And then it became, 2 years after we did the research out in the literature and people read about it. And it was sort of it was just this is the thing. And good luck getting better than this unless you figure out some new data source or new way to look at this thing. It was just sort of everybody was doing. You could do about that well if you reproduce the results. It's very scientific, but what you guys are talking about doing is iterating on the fly in a way that you wouldn't have even been able to do a few years ago just because there's new technologies come around the corner. I will say, I just want to contextualize this a little bit because it's really important to me that that we sort of get an idea for what this is, because ultimately LLMs, and in so much as what we see in general society, are a tool that is very democratizing. It's the most democratizing thing I've ever seen in my whole life. I mean, in medicine, Nick and I, in our specialty, in all fields of medicine, we condescend towards Dr. Google. Okay, he's the most poorly trained doctor in the history of the world, and everyone has used Dr. Google and think it's looking up medical things. Questions for medical problems is the number 2 thing people search on the internet, behind the other thing that we all know is the number 1 thing on the internet. And LLMs are a million times better than Dr. Google. They're trained on the whole internet. Of course, they're going to be good, right? So it makes perfect sense that patients will go there for medical answers. It also makes sense that they'll go there with their medical data and ask about it. Why wouldn't they, right? So we need to be prepared for that. That's a democratized set of knowledge. It's essentially like a doctor in your pocket or whatever you want to call it, right? So contextually, this is something people are doing. They're already doing it, right? When I go into the room, patients record me surreptitiously, usually. They will have family members on the line looking things up when I have conversations. This is the real world we're living in. And the thing is, you can't truly benefit from the democratizing power of LLMs unless it's something that can go directly to the end consumer. And it has to be something that, in my opinion, when you're talking about patient education, patient information, stuff like that, it has to be something that they can use, and it has to be something that doctors can trust, right? So then you get into the world that Nick and I inhabit, which is one of risk-bearing behaviors. We, in emergency medicine especially, I guess all specialties, but in emergency medicine, we are always calculating possible outcomes based on our actions, right? If somebody comes to the ER with chest pain, they look fine, their tests are normal, they didn't have a heart attack, they could still have a heart attack within the next couple of days or next couple of weeks. There's a non-0% chance of that. And so we're well, we usually are well, it seems low enough that I can send him home. He can get to see a cardiologist before then. Or it's high enough, I want to keep him in the hospital for more testing. Or it's high enough, but this guy doesn't want to stay here, so I need to help him understand the risk and have a conversation with him about it. And so I think doctors in general are comfortable with, I think they're comfortable with non-zero risk, provided they understand what goes into it, what builds that risk up and decreases that risk, what they can do to mitigate it. And I think one of the problems with LMs, they're just kind of hard to understand, I guess, how it works, right? And the output is telling you something, but it may not explain it perfectly. So anyway, that's the world we're coming from. But I guess big picture is I don't think medicine should sit back. Medicine, the house of medicine, should sit back and say either this thing is perfect, i.e., through the FDA and does everything right, and we know exactly what the output is, and we know what the output statistics are. Either it's that, or there's a doctor in between the output of this and the nurse or the patient or the family or whatever. And I think that's just because, like, we all kind of like are anchoring on what LLMs were a year and a half ago, which apparently is like, might as well be, 10 years ago. So I'm going to get off my soapbox a little bit and just kind of like see what you think of that, and see what you think of, like, especially you, Mac, like as a non-physician, what do you think about the idea of being able to use these things for your own betterment without a doctor having to worry about how good of a job it's doing, and, being immersed in this world yourself now at this point? Where are we getting on the graph of trust? Like, are we up on the up top right? Or are we down on the bottom right? Like, where are we on this, like, 2x2?
Yeah, I think it definitely depends on, like, little who you are. Like, I use LLMs for everything these days, right? Like, where should I go holiday? Where are the best surf beaches in Japan? Like, so of course I'm gonna ask it all these health questions, and I'm probably gonna trust it reasonably. And I come from a family of doctors, so I'll ask my family as well. Um, I'm sure in the ER, you two are constantly bombarded with questions, or people that come in that have already self-diagnosed themselves completely, asking for treatment and things like this. So I'm
Pretty much.
I probably happens daily, right? So they're clearly trusting Dr. Google completely. I think you're right that LLMs are trained reasonably well, so they probably do a good job saying you might have this instead of you have this, and you should check with your healthcare provider. So,
yeah, if you put disclaimers around and protect it, I mean. So, Mac, do you ask your have you shown your family members what we're doing?
Yeah, absolutely. So,
they think it's crazy, or what? Are they? What kind of doctors are they?
They love it. So mum's a nurse practitioner, so she's in the family as a GPs over the place. But dad's an oncologist, so he's using like OpenAI O1 and other models to like self-review himself. He also has kind of a more specialist private thing where if a pilot somewhere in Australia or New Zealand is recovering from cancer, he needs to evaluate the risk of whether they can go fly commercially, I think. So it's a bit niche, and often, it'll depend on like recent research and remission rates, things like that. So he finds it super helpful. He doesn't completely kind of trust it, but it makes his job easier in that sense.
Yeah, I feel like all doctors are using this stuff now.
Yeah.
I tell anyone that will listen to me that we've all moved from geek to nerd, and we just need to get people from nerd to just like regular. So definitely the people who know about this stuff and use it right now are definitely in the nerd space, but the nerd space is much more familiar to everybody because, I mean, frankly, most doctors are pretty nerdy. Not you, Nick. You're not nerdy, but
no, thanks.
Yeah.
You make a good point though. Mac is, doctors are using this stuff to learn. Like, I can't even tell you how much stuff I've learned from like ChatGPT. O1 model is incredible, and I think that should really say something. Like, doctors are trusting it to teach them things like that. It's not perfect, but give it a year. I mean, it's going to be wild. Yeah. So I think that really says something.
Cool. So are you hopeful about things, Nick? Are you cautious, or more cautious than you were when we started the GPT journey and now moved on to the other models and everything else, or what?
It's a good question. Because I'm hopeful is the bottom line, but I am cautious about the importance of giving the LLMs the data that they need. And that actually applies to patients as well. Like, if patients are using these things, if you have a health problem, it's the same problem as Dr. Googling, I think. Google uses language models too, but the problem is that if you say, I have right lower quadrant abdominal pain, that could be a lot of different things. I actually tried this today just for fun. I was like, I have right lower quadrant abdominal pain. What do I do? because I wanted to see the level of, advice or non-advice it would give me. And it made an entire differential, which was great, but it wasn't really digestible to a layperson.
Mm-hmm.
I would say if you don't give it enough information as a patient or as a physician or as a tech company, patient experience company, like that's where the limitation is. It's just going to be garbage in, garbage out. But the models themselves are very optimistic.
Okay. Mac?
Yeah, definitely super optimistic. It does feel like things are accelerating, which is scary because they're already going super fast. But I trust in healthcare generally to force things to slow down until they're reasonably safe. So I'm optimistic.
Do you see us getting to a sort of asymptote of quality when we begin to start asking these LLMs to take the next step, which in my mind is, okay, I already assume that all these new LLMs are trained on the whole internet. I know it sounds naive, but I'm assuming they downloaded the internet, all of Reddit, all of Dr. Google, every random video on YouTube. I don't know. It doesn't matter. But the long story short is they're not trained on all the medical notes in the electronic health record, as far as I know. I know there are companies trying to do that, and they're trying to be proprietary. I kind of feel like the next step that the models will take will be when they're trained on that corpus or fine-tuned on that corpus. And then I guess the last barrier to real success will be a training set that is the conversations and interactions between like my patients and I, right? Being in the room, recording it, having that, because it's all well and good to take someone's medical record and everything on Dr. Google and come up with recommendations for patients. But if they're sitting in the room saying something totally different, which one's going to outweigh the other? And are you taking into account preferences and things like that based on speech patterns, tonality, intonation, emotional state, and all those other kind of cool things? So those are like the next steps I see taking. I don't know when those are going to happen, to be honest with you, but I guess I'm sort of optimistic. I think that the large electronic health record vendors will make that next step difficult, possibly impossible, because they'll try to do it themselves, I think. But maybe that's the next thing we need to do to be able to succeed. Not sure.
It's a really interesting point because definitely all the AI labs, so like OpenAI and Anthropic, have gotten to this point or just before this point by taking the internet, which is free. They could just scrape it.
Yeah.
And now everyone's rushing to find those like honeypots of data that no one else can get, whether that's YouTube data, what are the HR records and things. So I think we will see divergence in model capabilities in, specific use cases like healthcare as they unlock those data sets from AHRs or whatever deals they can find. So it'll be one to watch.
Yeah.
Justin, you had a really good point a few weeks ago when we talked, which is that you could try to train models on clinical notes and clinical data, even at the best health systems, and it's still going to just carry over the diagnostic and treatment errors that are present in all of healthcare. And so I think, that's I think important to realize. Like, I don't think you can just have like that be your data set. I think you really need, randomized controlled trials, guideline data, scientific reviews, that kind of stuff. I still think that meticulous, well thought out medical training kind of like that's what medical training is all about. And I think it's, I do think it's a limitation that I don't know if everybody sees that limitation as you laid out.
Yeah. I mean, you were talking about garbage in, garbage out, but like, what if the only thing you can feed this monster is garbage? What if he is Oscar the Grouch? You know what I'm saying? Like, how are you going to turn like the brilliance of medicine on its head, the brilliance and the entropy of medicine on its head, if there is no Dr. House? You know what I'm saying? There's no perfect, ideal gold standard of behavior. Like if you got every piece of data ever. Anyways, I still want to have a tricorder. I'm going to have one day before I'm dead. I'm going to work clinically until I can have one. But at the same time, we'll see. We'll see where this thing goes. So Anyways, thank you guys for your time. I think this has been very fun. I hope informative for anyone watching this. And then, of course, you can all have all of our contact information at the end here. So thanks, Mac and Nick, and have a good night, guys.
Thank you,
Cool.
Justin.